we have C to look at. So let's go. So C becomes x squared plus 2x plus 4 over x plus 1 cube. Now, when we look at this one, again, the denominator is cubic, the degree. The numerator is square, degree. And so it is in good form of proper fraction. But the thing we face is that we have x plus 1 cube, so we only have one linear factor, but it's raised to the multiplicity 3. And so the prescription there is, now you got to be careful, is to write this out as a over x plus 1 plus b over x plus 1 squared plus c over x plus 1 cube. So that's the prescription. Remember when we did the theory, if I could scroll all the way to the top of my page. When we did the theory, we said if the linear factor appears with multiplicity k, then we must, here we said if we have a linear factor with multiplicity k, this must be included inside the partial fractions. Okay, so all the way to the bottom, I guess we go again. That's the idea. So here we are. Okay, so now what to do? Well, we do the same thing. The only difference here now is that we have 3 fractions to add. We have a over b plus c over d plus e over f to add, and we can add those. In this case, though, it's made easy because the denominator is just linear factor raised to various powers. And so the way we do this, let me write it in this line, is to take a and multiply the top and the bottom by this denominator, x plus 1 cube. And so this becomes a. What is left is x plus 1 squared plus b. What is left is x plus 1 and plus c, and what is left. Again, the idea here is that we just go ahead and multiply by the appropriate thing to make the x cube. So here we'll multiply by x plus 1 squared, x plus 1 squared, because we want to get back to cube. Here, x plus 1 and x plus 1. So almost like we're asking, what is missing from my denominator in each case? And here, nothing is missing. So I'll multiply by nothing. And my numerator will be like this. On this side, my numerator is going to be still this guy. I write it here. I'll say x squared plus 2x plus 4. Again, the denominator is the same, so I don't want to keep writing the denominator, which is the same. I'll just say thus. So we write the numerator and stuff. So this is what we have again. And so we can now try that technique where we say, hey, take x equal to -1, just like we did before. Notice though, in that case, what happens? This disappears, this disappeared, this disappeared. We're left with c. That's good, but that's the only thing we can get. We can go ahead and take x equal to 0, that's work, and x equals to 1, that works as well. What I'll do for this problem though, sorry, I will transition to another technique. I will transition to another technique here, where we write multiply out the left side. So instead of doing these x's equals, I will go ahead and multiply out the left side and combine the left side. And so that's another technique. So another technique is to multiply this out. It becomes a into x squared plus 2x plus 1. Again, remember your binomial expansion. B into x plus 1 plus c equals to x squared, the right hand side, plus 2x plus 4. Now I will look and try and combine. If I go, I will get ax squared. So I'm multiplying out the left hand side. And then I will multiply a times 2x here, but I have b times x, so I'll combine those as well. So I'm looking at all the coefficient of x squared, looking at the coefficient of x. So here I will have 2a plus b, and that will multiply by the x. And then here I will have a times 1, I will have b times 1, and I will have c. So the constant coefficient there would be a plus b plus c. And on my right hand side, this becomes 2x plus 4. That's the idea. Now I can compare. We have two polynomials. I can compare a to 1 on that side. So straight away I can say a is equal to 1. I can compare 2a plus b. That must be 2. So 2a plus b must equal to 2. And a plus b plus c. A plus b plus c must be equal to 4. So that's the idea. Does that make sense, guys? Hopefully. So again, we just have two polynomials on either side. Mr. Blandon, thanks for checking in. We have two polynomials on either side, and that means then that we can equate the coefficients. So a is equal to 1. That's done, nothing more to do. If a is equal to 1, we have 2a plus b is equal to 2. It must be that b is equal to 0. So this one gives us b is equal to 0. And we have a equals to 1, b equals to 0, and c plus c. So we have 1 plus c is equal to 4. So it means c is equal to 3. So that's how we get all these terms. So that's another technique. One technique that we used before is just simple to say, hey, take x equals to 1. Take x equal to, nice convenient points. This technique is to multiply out the left-hand side, then equate it to the right-hand side, and gather the coefficients and compare them. So that's the technique that you can do. Great. So the moment I do that, then I'm in this place where I go back as I right. Here is how we wrap this up. We say thus. I'll write it in here. X squared plus 2x plus 4 over x plus 1 cubed is equal to a is 1 over x plus 1 plus b is 0, so we won't write that, plus c is 3 over x plus 1 cubed. Usually if you have time, you can give it a little check to make sure we're in good shape. But this will be your final answer.